All right, so good morning, everybody. So this is PreCalc again. I had actually, I'm going to change from 3.1. We had a couple of questions the other day about function composition. So I thought maybe we should look at that. Okay, so why don't we look at 1.8 and preview this. All right, I think this one is on the pretest. I'm not saying anything, I'm just saying that, it's one of my more favorite questions, which I know is everybody else's most hated question, which is this one. All right, so why is this an important question at all? Okay, oh, dang it, I'm not used to, there we go. So a lot of times in life, you get experimental data and you don't get, a nice curve. So I know we spend a lot of time teaching curves and teaching shapes and all of that stuff. But the reality is sometimes you just get a bunch of dots, a bunch of lines, and maybe you can connect the dots some places, but it wouldn't make sense to connect the dots in other places. And then you end up with this mess, all right? So one of the things you might want to do is like, well, what if some of these things are additive? What if some of these things are multiplicative? What if, all these would be multiplicative. Division is multiplication, just in reverse. But what happens if you have to take your output from one and put it into another process, right? You might get a chemical reaction where the output of the chemical reaction is the input for the next thing, and then that's the input for the next thing, and so on. Okay. As a matter of fact, I remember taking a risk management class, and the way he would raise questions is the output of question one was the input of question two. Okay, don't do this. If you're another teacher, don't ever do this. It was 6 questions, and rarely did anybody get more than a 50%. So, because if it was wrong, if your output from the first question was wrong, then you were not getting question number 2. Wasn't going to happen. He didn't even bother grading. He was like, nope, it's gone. So you have to be careful about that. Okay, so more to the point. What about this problem? Because this is the thing confronting you in your life right now. Okay, so we've got this horrible picture, and it's going to ask you for different things. Okay, so this is m plus p of -3. Okay, so this is m plus p of -3. Now we can't do this together. Okay, we have to use what functions mean, function notation means to do that. Okay, and it works for multiplication too. Okay, it's not a distributive property. If you had an n times p, we would say, well, this is m of -3 times p of -3. All right, so we're not distributing. We're applying the 3 to each of these pieces here. Okay, or I should say maybe we are distributing, but it's weird. So yeah, actually you really do already know how to do this. We evaluate functions individually all the time, right? If I had an x squared plus 3x and I said find f of 1, well, we don't think about this as one thing. We do x squared plus 3 times 1. We evaluate this one, the m, plus the p, and get our answer. All right. So we naturally do this of evaluating one at a time. You wouldn't look at this as one thing. You look at it as 2 things. Okay. So how are we doing this problem? I should probably move this over a bit because we need like a good picture, and I'll move this over a bit. So m of -3 and p of -3. Okay. So here's the blue one is m. M of -3, that's 0. So we're going to say m of -3 plus p of -3. We have a 0 plus, and then our p of -3, we go all the way up to the pink, that's 4. So this is just 0 plus 4 is 4. Okay. Next one we have down here is p minus m. Okay, and we're going to effectively do the same thing here, right? We're going to say p minus m of -4 That's P of -4 minus M of -4. Now we're not doing anything with the negative signs because this is a location, not really a number, okay? So we have P of -4, we have -4 of here, P is still 4, okay? Now M of -4, that's -2. So we have a minus, and I put a -2 in here, all right? And that's going to give me 6. There's 6 units between M and P here, all right? What about M over P? M over P of 3, okay? Now, what we're going to do is we're going to do this, M of 3 divided by P of 3. Now, you got to be careful because if this is 0, right, then this whole thing is undefined. So we got to be a little bit careful here, but let's see what's going to happen. Okay, so we have M over P of 3. So we have M, right, and we're going to go 1, 2, 3. M is 2. And P of 3, right, that's the pink, P of 3, oh, P of 3 is 0, right? P of 3 is 0. So this is undefined, okay? And one of the things, and I know students often get this mixed up, I think you guys, at this point, you've probably outgrown this, but a lot of times people will do this, okay? Check yourself. If you know you have trouble confusing, when you're confused by this, let's see what happens. Let's undo the multiplication, all right? Let's undo the division rather, right? And we cancel that and we get 2 is equal to 0. Now you know that's nonsense. You got it backwards, so undefined. Okay, so if you know yourself and you know you have problems with this, double check, and this is how you double check, okay? In this case, it's undefined, all right? M of P of 0. Okay, so well, if it's 0, it's going to be 0. No. Again, the 0 is a location. It's not a value. Right, so we have M of 0 times P of 0. Okay, well, M of 0, that's 4. P of 0, that's 2. We end up with an 8. All right, let's see here. Now we get to the circles, okay? So POM and MOP, all right? So POM of -2, okay. So P of M of -2. So what's P of -2? Well, actually, let's not, no, P of M, yeah. So the way I like to write this, P of M of -2. And we're going to work inside the parentheses to outside the parentheses. So what is M of -2? Well, we're going to go over here to -2, right? What is M of -2? And that's 2. Okay, so the output of this piece goes into the input of P. And now I have to look, well, what's P of 2? Go over here, P of 2 is 1. All right, and that's what you would do here. Can you reverse them? Right, can we do that? Can we say M of P of -2? Is that going to give us the same thing? It might, but it doesn't have to. Okay. So P of -2 is all the way up here at 4. Right, P of up here is all the way up here at 4. So we have M of 4. Why do they do that? Okay, and then we follow down M, right? M of 4 is 1. So in this case, it was the same, but do not mistake, it's a coincidence. They are not going to be equal necessarily, okay? So the fact that we get that and it's a coincidence, that's fine. It's a pretty simple function, but that is not necessarily the case, okay? I should yell at them because MOP, oh, we want M of P now of 3. So we do M of P of 3, all right? Love it when people write a problem where if they do it wrong, you still get the right answer. I'm like, don't do that. Okay, what's P of 3? P of 3 is 0. Okay, so P of 3 is 0. What is M of 0? Well, M of 0. So the input was 3, and we went through P of 3, and we got 0. And then this 0 is now the input for M, and we're going to get a different output. So M of 0 is all the way up here, 4. Okay. So you have to be careful about that. Okay. That's probably the trickiest this is the trickiest part of these problems. Okay. But the thing you have to remember is, like, you're feeding, what are you feeding P? You're feeding P of 3, and it's going to put something out for you. And then as soon as you get the output from 3, you're going to feed it back into M, and you're going to get a different output. Okay, so you might have 2 chemicals here. You combine them, and then whatever chemical you get here, right, you're going to feed that into the next state of the reaction, and that's going to give you a different, right? That's going to give you a different. You get that, and then you end up with something else. Okay, so that's the idea, is that you're feeding, you're giving a function an input, it's giving you an output, you're taking that output, you're putting it into the next function, right? And then you're giving more. So if that works for you somehow, that's fine. Let's see, I guess we could come up with, like, what was that guy's name? Risk management class, right? You got test question 1, and you have some inputs, right? They give you some inputs. And then you get the outputs from question number 1, and you're like, yay, I got an answer for 1. Unbeknownst to you, it's wrong. Test question 2, garbage. And it doesn't, congratulations, you got a 1 out of 6 on your test. Well done. Okay, that's your grade. And I'm being a little bit unfair to the situation. Getting 3 right was an A. Okay, getting 2 right was a B. Getting 1 correct, right, you actually had to, like, if you had a sign error or something like that, you didn't, that was okay. But if you got if you only got this question kind of correct, then that was a C. So, and then a lot of people can make it past question number 1. Okay, but this output had to go into the next one for you to keep going and keep getting the question right. All right. So I wanted to make sure we did at least one of those when we were reviewing. We might revisit this and do another one next week, because I know these are rough. Okay. I also know that this is one of my more favorite problems to give you, talking about function composition. So we have to suffer with that. I do want to point out that, okay, not so bad, right? Still not so bad. So we got 2. Okay, a little tricky, but not terrible. And then up to 4, we've got this. So if you can do, right, if you're okay with getting up to 4 of these right, I gotta guess, I don't know, I never got it. I'm like, that's okay. You got a 4 out of 7 on this question. It's not the end of the world. Do not beat yourself up on it if you didn't quite get there. There are other questions which I'm sure you were great at, and it doesn't mean that you're going to sink your whole test just because you got a 4 out of 7 on one question. All right. So try to keep things in perspective with this. Don't panic. Don't beat yourself up. We'll do it again. We'll do another one on another day, and make sure that you got this. All right. All right. So the next to this is the delightfulness of interval notation. And if you're looking at these questions, like, I hate these. You are not alone. I am not as happy with these either. Okay. Oh, I got questions on this one too. That was a good one. All right. So what we have here, right? We have S times V, right? We have S of X is equal to, I'm terrible with that. I hate when books really insist on using S. Okay. All right. I make a cursive S, because if I make this S, it keeps looking like a 5. So we have S of X is X minus 2. So this is an S. Okay. I know they don't teach this so much anymore. X squared minus 16. The V of X is equal to the square root X plus 4. All right. So the first thing they're going to ask you to do is just go ahead and multiply it. Let's go ahead and just do that. So S times V is equal to X minus 2. And then I'm going to go ahead and say this is X minus 4, X plus 4. And then V, right, that's the square root of X plus 4. Okay. Now, they're being a little tricky here. What they want you to do is they want to take this X minus 2 over X minus 4. And then here we have the square root of X plus 4 times the square root of X plus 4. You see how they go back together and make one X plus 4? And then we have an X plus 4 up here. We're going to cancel these. Okay? That's going to cancel. So what we really have when we're done here, back to blue, okay, is going to be the X minus 2, X minus 4, square root X plus 4. Okay, that's what they want to see for this problem. Okay. We're going to have X minus 2, and on the bottom, what do we have here? We have an X minus 4, okay, parentheses, and then we have a square root X plus 4. All right, that's what they want you to do. All right, that's all they get. I know there's a part 2. What do you mean, no? Oh, sign X minus 2. Are you kidding me? Ah, maybe it isn't what they want. When was the last time I did this? I thought they wanted that other one. I could swear that they wanted the other one. All right, so I'm wrong. Oh, I need parentheses. Okay, that's what we have. Domain. Actually, I could have sworn I did this problem before. They said it was okay to put that square root on the bottom. All right, domain. This is where it gets getting a little bit tricky. Okay, this is where you do actually want to do this. Okay, because we need the domain here. So the problem with these problems, okay, the issue is here with V. What's the domain of V? All right, V says that X has to be greater than or equal to -4. If I put a -4 in here, I get 0, it's okay. Now we have to deal with this part. Okay, so this says, so the domain of S is X can't be 4, nor can X be -4. What we did is we set the bottom equal to 0. Now we used our zero factor principle. All right, and then we're ready to go. All right, so when I go through and multiply them together, I've got to take like the most restrictive case out of all of the parts, and then if something happened here, I got to take a restrictive case as well as here. Okay, so for this one, right, X has to be greater than or equal to -4, but if X happens to be -4, this ain't gonna work. So X has to be strictly greater than -4 for this to happen. But also, X cannot be 4. All right. So when we go to write down our domain, we've got -4 because that's the smallest number we can have. X has to be bigger than -4, otherwise we get a problem here. Up to 4 union, and then we have 4, and then we're free and clear for the rest of the numbers. All right, so we have to be careful about that. So we're going to have -4 up to 4. If this makes a liar out of me, I don't know. All right, and then we have 4. Oh, we need one of those. 4 up to infinity, and then we're good. All right, so there we go. Okay. All right, do we need to do a difference quotient? We probably do. We did a few of those before, but I might save these until next week. And we'll just work on this kind of stuff today. Oh, this looks terrible. I don't think I picked one of these. I might have, but I don't think I did because I find these to be extremely tedious. And then h is equal to, what's h? 4x minus 5. And we want f circle h circle g of 5. You have some choices if you wanted to solve this problem. Okay, we have some choices. We could figure out what g of 5 is, right? So we have f, we have h, we have g. We're going to feed g of 5, and we're going to get an output. And whatever output we have, we're going to feed that to h and get another output. And then we're going to feed that output to f and get the last output. And that's a legitimate way to do this. Okay. Did they ask us for anything else? They are just asking us for numerically deal with this. Okay. And I'm looking at this now and I'm thinking maybe this is the best way to go. Okay. We could also figure this out. We could also do f of h of g. We'll say of x, and then we'll put in a 5 when we're done. Okay. Which means what we have to do here is we have to say, well, what's f? F is to take a number and cube it and add 4 times that number. You say, well, what number would you like to add? Well, we'd like to add g, or h rather. We'd like to add h to that. So we want 4 times a different number minus 5. I don't like a circle there. Let's do something else. I didn't want to do a square, but I wanted something big enough. We'll do a rectangle. Okay. And we're going to have 4 in a rectangle minus 5. Well, 4 times a number minus 5. And then what we're going to do now is we're going to say, well, what number would you like to take, 4 times that number minus 5 of? And we'd like to take the square root of 5x. So we're going to put in the square root of 5x here, the square root of 5x. And then we're going to back all of this stuff out. As much fun as that sounds, I think I'd rather do it this way. Right? This looks like a lot of work to cube this thing out and to deal with all of this. Okay. So yeah, let's take a better way. So this is f circle h circle g of 5. Well, let's start evaluating. Okay, what's g of 5? 5 goes in. What comes out? And g, remember, g is square root of 5x. Okay. Well, that's going to be 5. Okay, so that was nice. Okay, so the thing that came out was 5. So it's this 5. Right? It's this 5. So this is the 5 that's going into the next piece. All right. And this goes into h of, again, 5. Not because it's 5, because 5 is what came out. So what's h say? H says 4x minus 5. You give me another 5, so help me. So h says 4 times a number minus 5. Well, that's 20 minus 5. That's 15. So out pops 15. All right. And now we're going to take this 15 and we're going to push it in over here. We're going to say, okay, here's our 15. And this is going into now f. And f says x cubed. Really? X cubed plus 4x. You like to write these things. You really don't need a calculator, but apparently the people who wrote this book have different thoughts, okay? Because I am not doing 15 cubed in my head. This is just not happening. All right, 15 cubed plus 60. I'm sure that'll be a delightful number. That was 15 cubed, my goodness. Why do they do this? All right, there we go, 34, 35. Oops. So I don't want to point, see, I want that. 34, 35. All right, there we go. All right, hooray. All right. I don't know if we need to do another one of these or not. I'll see. Let's scout around for a little bit more. All right, this is a good one. Smaller than the other one. Because we have n of x is equal to x plus 7. Q of x is equal to, what do we have here? 1 over x minus 14. Right, and what do they want? They want q of n. All right. So what we're going to do is we're going to, okay, what does q say to do, right? This is q of n. So we have q, which is 1 over, take the reciprocal of some number that we're going to subtract 14 from. What number would you like to subtract 14 from? Well, I'd like to subtract it from x plus 7. Great. 7 minus 14, x minus 7. Okay. Now, they're going to ask us for the domain next. You're going to love this. You have to take the most restrictive of everything that happened. Okay. So the domain here, you might think, what, isn't it just x equals 7? No. Right, it's not going to be x equals 7. It's not going to be this. Union 7 off to infinity. It's not, they're not going to like that. No, 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 no. Oh! All right, the reason why they liked it was because the only way to get 7 out of here, no. The only way to get 14 out of n is to put 7 in here. That's why. Because normally you would not want x to be 14 either. I'm not doing well today. All right. Oh, no, that's tedious. All right. Let's see here. Oh, don't know if I put one like that. I mean, let me go to our pretest. I just want to make sure we're staying on target with stuff that you're supposed to be saying here. All right. All right. All right. Let's take a look at a couple of these. All right. Okay, let's go to the beginning part because I wanted to make sure I wasn't pulling in too much. Okay, difference quotient. There we go. I'm not going to do this problem. I'm going to do one just like it. Okay, but okay. So difference quotient. All right. So what if we are given something like 1 over x plus 13. Okay, so find the difference quotient, x over x plus 13. So a difference quotient is, now, I'm sorry for this. All right, I do pull them right out of the problem. And normally in a face-to-face class, I would say find the difference quotient, comma, and then write you the formula and simplify. And I do not have the ability to do that on a question like this. All I have to do is pick this problem. That's all I have the power to do. So we're going to have to remember the difference quotient. Okay. So every time you do a problem like this, write down the formula for it. That way you associate difference quotient, formula, and you'll be able to do the problem. Okay. So, and it's a good habit to be in anyway, because when you get to be bigger formulas, when you get further along, you're going to have more complicated formulas, and the biggest error you're going to get is putting the wrong thing in the wrong place. All right, you do not want to do that in the workplace, because if anything gives anybody else a chance to undermine your ability to do this, it's going to be mismatching a number in a formula. You will be teased relentlessly at that point on. I think the only thing worse you could do is confuse meters and yards. Okay. So if you went to Catholic school, well, if you went to Catholic school in the 70s and earlier, you will know that a meter stick is a little bit longer than a yard. If you swim, you'll know that too, because it makes it painfully obvious. But 1,000-yard swim is not quite as brutal as a 1,000-meter swim. If you sat in the second row, that yardstick wouldn't quite hit you if the sister was upset with you. So if she wanted to hit you across the head with her stick, yeah, this is the way that actually, this is what they actually did. Right? They wanted to hit you across the head with their stick because you were mouthing off to her. All right. She couldn't hit you if it was a yardstick. You could dodge and it would miss you. Not by much, but you could dodge. If it was a meter stick, the corner of that thing would hit you right in the nose or right on the forehead. It would hurt. So if you're mouthing off to sister, he's like, if you take one more sound, I'm going to whack you with this. The next thing you would ask, sister, is that a meter stick or a yardstick? And if it was a yardstick, then you knew that was an empty threat. And she'd have to come after you, which she didn't want to do. Okay. So all we did here, we just got common denominators. Okay, that's all that happened. All right, I said x plus 13, top and bottom, x plus h plus 13, top and bottom. Okay, that's all we did. Do not multiply these bottoms out, okay? That is intimidating. It's awful. Please don't do that. Okay? But more likely than not, she would tell you it's a yardstick, and then you would know that you could continue doing whatever you wanted because she won't hit you with it. Or she would try, but you could dodge. Then they learned, after the first time, they would just tell you it's a yardstick. You'd say, ha, I don't have to fall for this. And then she'd whack you. Like, sister, I thought you said that was a yardstick. She said, I lied. You're not supposed to do that. I'll go to confession later. So if you need help remembering if a yard is bigger or smaller than a meter, just remember your parents went to Catholic school, or you remember me going to Catholic school and then getting smacked by the sister, lying that it was a yardstick. Okay, so here, right, the H, that was the only thing that stayed the same. all right? Everything else is gone. And the question is like, wait, am I done? Why does that look like an answer? It doesn't, right? You're looking at this thinking, there's no way this is an answer to anything. I'm saying, no, this is the answer. And the reason you know it's the answer is because at the beginning of this whole business here, what we wanted to do was we wanted to make sure that this H here, that we canceled this H. When you cancel that H, that is when you were done. Okay, so we'll just track it. Here's that H here. Here it is. Here it is. And then here is where it got canceled. Okay, that's how come we're done. Like what happened to the H up here? Whatever happens up here is its own business. We don't care. It's nice that it all canceled out, but until you cancel this H, you're not done yet. Okay, this is when you're done. This is when this is gone. All right, and I know that looks like a terrible answer, but that's the answer. All right, it's just the way these things turn out. You have to get used to the fact that these do not look like answers. Okay, they just don't. And I'm sorry about that, but they don't. So that's a guy there. That's a difference quotient. All right. So next week we have our exam proper. We will go through and we will make sure that we review everything. If there are people watching this, I promise I will put these up today. Well, today or tomorrow, I'll put these up on YouTube. But if you have questions about what's going on with the exam, let me know. Okay, so we can try to focus on that problem. But next week I have planned to do another one of those like FG graphs that we have to deal with. We'll do more difference quotient, and then we'll do rational functions. Because I think those are the hardest topics that people tend to have to deal with. All right, we'll do those. All right. So with that, I'm going to go ahead and stop recording, and I wish you guys all good afternoon. And good luck this weekend studying.